Hello everyone, today is December 1st, 2025, and today I'm going to work on this LeetCode number 1004, max consecutive ones 3. So the question is like, we're given a binary array. Binary array means all the elements are either 1 or 0, and also another constant k. The question is asking us how k is the maximum number of zeros that we can flip, and after flipping we can get the longest length of all one subarray there. So we need to find out the longest all one subarray size. So this is one example. So there are 4 consecutive one here. You can either flip this and this, or this and this. Either way, we get a 6 consecutive ones in this sense there. So that's the maximum number of consecutive ones we could get by flipping maximum a 2 zeros there. So we just need to return the maximum length of all one array without the need of finding it there. So this is another example. So here, if we flip these two, then this part of all ones and this part of all ones and this part of all ones all connected. So we construct a big one list there. So the maximum length of the all one sublist is 10. So the way that we can implement this is basically using 2 pointers. So basically we have a left pointer and a right pointer. So the right pointer will just keep searching to the right until we have too many zeros. So we can, let's say if we keep going from this way, we have 2 zeros, so that's fine. Then we have at this point, we found a length of 5 of all one sublist there, and then you keep searching to a point that they're 3 0. This is larger than k. Then you should not keep going. Then you should shrink the left side. So until you shrink it to the 0, to the first 0, and then we still have 3 zeros in a sense. Then we should keep increasing left until it gets to here. Then we have 2 zeros. So 2 zeros is within the allow limit of 2 that we can keep searching until it goes to here. It will find a maximum number of 6 there, and keep going to the end of the list. So I'll just start implementing. So initially we can initialize the pointer. Let's say left equals 0. And then we also need to keep track of the number of zeros equals to 0 at the beginning. And we also need the max length variable. Let's also set it to 0. So there are only n possible way of right. So we just go through each one of them. So for a right in range length of nums. So this is all the possible ending position of right. So we're gonna do it from the left to right. If nums the number equals to 0, then we need to increment num zeros. Num zeros plus 1. So you will keep going until eventually it probably would accumulate like too many zeros there. Then we need to shrink the size from the left until you will find until you make the list valid again. So basically, while num zeros is still larger or equal to k, then we need to move the left pointer. So if num's left is already at a 0 position at the beginning, then we should decrement the num zeros because we cannot move the pointer. And then we need to move left +1 there. So this part is a little bit tricky. Probably need to like stare at the code long enough to understand this. Basically, we cannot move the pointer first. We have to check what the current number of the left pointer is there. If it's a 1, then we'll just skip everything here and move the left pointer. But if this is 0, then we need to do the accounting, like remove the number of 0, reduce the number of 0 by 1 before moving to it there. So after the while loop, so right now we have like a valid and a position. We also have like a valid left position there. So we should update the max length there. So the max length should be max of the current max length and the length from right to left. So it should be right minus left +1. +1 is because we also need to count the current number that left is pointing to there. So it will count like a inclusive, like from left to right, all those numbers there. So if we don't have +1, that will be exclusive of the start point. And then, so the for loop would end to the end there. And for the last right, then you would guarantee to find its valid left there. So at this time, we can confidently say that it checked all the possible lengths there, and we can probably just return the maximum length that we found during the loop. And let's try to run the code, small test. And this is just a typo, so n zeros, let's fix it. Let's run the small test. Okay, so let's see what's going on. One one zero 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 k equals 2. We output 5 and we're expecting 6. Probably something related to this while loop here. So if the num zeros it's larger or equal to k, is this the right condition for us to keep move the left pointer? If num zeros it's I think for k is allowed there. So if like we only contains like k, we probably don't need to like move the left pointer yet there. So only larger than k. then we need to shrink the size there. So if, let's say, you only find like 2 zeros, if k equals 2, then the right pointer can keep exploring to the right. If you don't ever encounter 0, then you can keep increasing the length there. So that should fix it. Try the small test. Yeah, it passed. And the big test. Yeah, both the small test and the big test passes there. So let's do a little bit recap. So we have like a left pointer and a right pointer. Basically, the right pointer would continue searching until it finds like too many zeros there, and then the left pointer will start moving, and all the right pointers would only go through each element by once there, and it's the same for the left pointer. The maximum number of elements that you can hit is O of n there. So the time complexity should be O of n. And for space complexity, we only have like 2 pointers and like some constants to keep track of the status. So there's no actual space. This is a constant. So the space complexity should be O of 1. Yeah, that's it for the solution. If you found this video helpful, please smash the like button. It really helps support the channel. And don't forget to subscribe for more content like this. Subscribing also helps the algorithm recommend similar videos to you. Thanks for watching, and I'll see you in the next one.